So arithmetic sequences. You know, in the past you did some arithmetic, and that's how you get used to seeing that word read. But if it's describing something like a sequence, then the way that's pronounced is arithmetic. So no, I'm not making a mistake there. So with arithmetic sequences, a probe is attached to a hot air balloon to measure air quality. You know, you can picture one of those big balloons. Probably wouldn't have like necessarily a spot for people to sit in, so maybe don't picture that, picture something more scientific. And so as it's released for air quality and measuring it, after 1 second, the probe has an altitude, which is a fancy word for height. So if that's new to you, go ahead and underline that and put height of 6.3 feet. So as you're reading this, if you want to just start writing in these numbers, that's totally cool too. Then 14.5 feet after 2 seconds. The only thing going here is trying to trip you up by changing the order in which they tell you things. 22.7 feet after 3 seconds. Create a table showing the first 8 seconds of this trend. So here's the table, and I went ahead and made this in the notes for you, so you don't have to do this by hand. So it's like the input is the time, and the output would be the altitude in feet of the object. Now these little downward V's connecting 6 3/10 to 14 5/10 are there so that I can see that these are connected somehow. So if I want to figure out how much I'm adding to 6 3/10, I can take out a calculator and do 14.5 minus 16.3, or I can kind of just count up in my head and say, well, that's 8.2. Now we assume that this moves the same, but it's kind of careless to assume. So if you pull the calculator out, do 22.7 minus 14.5. And what we'd see in that is that we are, again, adding 8 2/10. And what this is telling us is that this sequence of numbers have a pattern, and I can keep on adding 8 2/10. So go ahead and complete items 4, 5, 6, 7, and 8, but then also show that these two values connect just for a little bit more practice. You don't have to rewrite that for everything, but just make sure you connect 3 and 4. Fill in 4 through 8. I'm going to put the results up in just a moment. Check to make sure you got the same values as I did. And usually it's nice to look at the beginning and the end of the tables. So there's 8 giving you 63 7/10. And the key concept is, there's something that is a numerical pattern. So I'm jumping down to the definition. So the thing that I want you to fill into this blank is the words arithmetic sequence. So what this says is that an arithmetic sequence is a numerical pattern, so this doesn't involve shapes is what it's saying, that increases, and in this problem above we're definitely increasing, or decreases at a constant rate. And what this means is that this value that it's increasing by doesn't change. It's not like it goes up by 8 and then 16 and then 32 and 64 and so on. So this one that we looked at increased at a constant rate or a constant value, which is known as the common difference. In helping understand these words, well, difference means we can just find how far apart they are from each other, and difference also means subtraction in math, so we subtracted the first term of 6.3 from the second term to find their difference. And since these all were the same, that makes them common. So that's where this word common difference comes from. I broke down the vocab more than most teachers would, so hopefully that makes clear sense. Identify arithmetic sequences. So this is one of those typical things they do at the start of a math concept, where they make sure you can recognize what you see. So in determining whether each of these is arithmetic, we're going to rewrite 1, 2, 4, 8. And really, if you wanted to, you could approach this a couple different ways, but if you're looking for the pattern, to 1, how would I get from 1 to 2? I'd have to add 1. So their difference would be 2 minus 1, which is 1. Here I'd be adding 2. Here I'd be adding 4. And whether it's arithmetic, I'd say no. It's not arithmetic. No common difference. You could use different words. You could say it goes up by different numbers every time. You could say it goes up by 1, then 2, then 4. However you do it, find words that help to make things clear. You also might have noticed that it's just being doubled every time. But again, that is not a difference, that is a multiplication. And if you double something or divide something multiple times, that's actually called a geometric sequence, which you won't do in this chapter. Number 2, this is going to be OYO, and then depending on what answer you get, make sure you explain it. I'm going to put everything up in 5 seconds, so pause the video and do it on your own. So yeah, this one does have a common difference of 4. So for that one, we'd say yes, it goes up by 4 every time. You could also say yes, it has a common difference, but my fear there is that as you start to use that wording, maybe you're not even thinking about it, and you're just kind of echoing what's going on. Number 3 is also an OYO. I'll talk about it in 2 seconds. Well, one way to look at it is it goes up by 3, then 5, then 7, so no, the answer is no, it is not arithmetic. But then there's also the real hope that you guys start to recognize 1, 4, 9, and 16 as being the squares of increasing positive numbers. So you got this whole numbers just being 1, 2, 3, and 4, and 1 squared gives you 1, 2 squared, and so on. Now on purpose, I'm going to slow down a little bit, and we will do number 4 together. So here's here's problem 4, beginning with a half, beginning with a fourth, beginning with 0, and then negative 1/4. So your first gut instinct might just be to quickly say no, because it looks kind of different. But we should be thorough and double check and make sure we're good there. Now one option is to get a calculator out and just subtract these numbers. But as I add and subtract fractions, it's nice to have a common denominator. So let's go ahead and change everything to where they're all out of fourths. And as silly as it may seem, I'm going to write 0 over 4, and then negative 1/4. And to get to these next values, I wouldn't add on a fourth, I would subtract a fourth, to go from 2/4 to 1/4. Going from 1/4 to 0/4, I would again subtract a fourth. And from 0/4 to negative 1/4, again, negative 1/4 is the difference. So the answer to this one is yes. I'm going to purposefully use different words. Common difference of negative 1/4. And you would say negative 1/4, not 1/4, because it's decreasing as it goes up in the pattern, up in the sequence. So in summary, just a little bit of a word problem as a lead into the, kind of what this sequence would look like, where the numbers increase at a steady rate, a little bit of vocab, some words that are somewhat challenging but not too crazy, and then this new way of kind of writing this out and then answering, common difference problems.